Rahim, this is a June 1741 variant in question number 6. What the question is, a particle moves straight line from point O. So it means it's starting from O, very clear approach. When it's starting from O, so it means when time is 0, velocity is 0, and distance also 0. But he's saying that this velocity formula given by him after this, and particle has a 4 when time is 1. So in the middle somewhere, time is 1 and speed is, velocity is 4. And there is another thing mentioned, velocity is 4 when time is also 2, also 2. So it means time is, let's say here, time is 2 and velocity again 4. All right. So we have to show time is 0.5 and acceleration is this much. 4-mark question. So first of all, I will use this equation qt plus rt to power 2. And you know it very well. This point lies on it. This one I will plug in here. So put t value 1 and v value 4. And when I plug in 4 here, and this one comes here, 1 into q will give you q. 1 to power 2 is 1, I get r. Equation number 1 done. Now same approach, I will say second part. Put time is 2 and velocity is 4 this time. Again, I will plug in velocity, velocity 4 once again, but this 2 goes there. 2 times 2q become 2q. And 2 goes there, 2 to power 2 is 4 and 4r. Equation number 2. Now I'm going to solve them simultaneously. Okay, and I think so better approach if I cancel q, what is here 2, what we need here 2. Upper equation multiply by minus 2. Then what happens? Negative 4, it's negative 2 into 4, I get negative 8. Negative 2 into this, I get negative 2q. Negative 2 into r, negative 2r. Lower equation, just copy. So let's see now. This cancel out. And here I get negative 4. And here I get 2r. And 2 divides on the other side. And r value minus 2. Alhamdulillahi Rabbil Alameen. Now this value of r, either plug in 1 or 2, no problem at all. I plug in 1. When I plug in 1, so student, what happens? 4 equals to q plus minus 2. Minus 2 goes there, become plus. So ultimately, I get q is equal to 6. So alhamdulillah Rabbil Alameen. First part is clear. And he was asking, no, sorry, not clear. We have to answer one more part. He said when time, show that when time is 0.5, acceleration is 4. But problem is that, do we have acceleration equation? No. Put both values back in the velocity expression. So I get this q value goes there. I get a 6t and negative 2t to power 2. Now I can get it now. He was asking that, show that when time is 0.5, acceleration this one. So first of all, do we have acceleration? No. I will differentiate, and you know it very well. There are 3 levels. If I have a displacement, if I differentiate, I get velocity. If I differentiate, I get acceleration. Differentiate, differentiate. If I come down, it's called integration criteria. So I am on the velocity level and I need acceleration. So I will differentiate. And when I differentiate, my students, here I get acceleration, 6 derivative t becomes 6, and 2 comes down and power 1 less, I get this. So plug in what here, time is equals to 0.5. And when I plug in 0.5, because he's asking that, so it must be 4. Let's see. So acceleration equal to 6 minus 4 times 2.5, it give us 2. And finally, I got 2 meters per second square proved. So this part is done, part number 2. So part 1 is done, and part 2, find the values of t, not 1, 2 times maybe, when particle at rest. And what is the target? It is the easiest job. I will plug in velocity equal to 0. Where is velocity? This equation. And when I will say that for rest,
Sir,
yes, please.
Sir, in the question it says acceleration should be 4, right?
Exactly. Oh, sorry. This is a, let me check. Yes, it's coming 4. Thank you very much. It is 4 actually. And I wrote 2 by mistake. Thank you very much. Thank you very much. It means 6 minus, because this become 2. And 6 minus 2 give you 4. Thank you very much. Let's move on next. And for the rest part, what is the technique? For the rest part, I will put velocity 0. And when I plug in velocity 0, students, where in this equation? So I get a 6t minus 2t to power 2 equal to 0. And one choice only, we have to take a 2 and t common out. I get 3 minus t. I have two options, either 2t equal to 0, or second option 3 minus t equal to 0. So I get 2 times 2t equal to 0, one option, 3 minus t equal to 0, second option. And 2 divides under 0, I get 0 and time becomes 0. We've got 2 times he was asking that find the value of t when it is rest. So alhamdulillah rabbil alameen, nothing hard up till now. Let's go for third part. Third part is asking what when particle is at O time is 3. What does this means? It means when particle goes away and come back to observer, displacement will be 0, as you know, when particle is at O. So it means this is a very clear approach. He said find the distance of P from O when time is 0. Or actually, it may be not starting from observer. Maybe it's starting from other point, from not from observer. Distance of P from O when time is 0. So, but first of all, I need displacement expression. I am on the level of velocity expression, which is this one. If I velocity level, I need displacement, so I will integrate. So let's start. 60 minus 2t to power 2. And as I will integrate it, so what happens integrating? So I get displacement equal to 60 minus 2t to power 2 dt. And s becomes increase the power by 1 divided by same is increase the power by 1 divided by same plus c. And you know it very well when particle was starting. See, when particle was starting, so that was the time was and but he mentioned here it was when particle is at O, this time is 3. Okay, and the distance of P we have to find. So this is a very clear approach when time is 0. And wait a minute, let me just confirm from here. Yes, students, so we have two choices. One is with plus C and one is with the limits only. And because very clear when time is at 3, when particle at O time is 3. So it means it is, we can find it easily with limits 0 to, one is a choice is a C3. Okay, and second is the direct limits, like put 0 and 3 and then no need of C. We can find even that. So I think so this is a better approach. I think we can save our time. And limits is 0 to 3. Okay, and here I got it 3 and 3 to power 2 minus 2 over 3 and 3 to power 3. Upper limit and lower limit will give you 0, so no need to check. And first answer is coming 27 minus 2 divided by 3 times 2, 3 to power 3. And my answer is coming 9 meters. So this is a one way. Second way, if you plus C writing, and you must plug in this limits. He said when particle times 3, displacement is 0. How I know? Because very clear particle is at observer. And when at observer, displacement always 0. So even if I do this integration with a plus C, I will plug in that limits and then I will plug in T3 to get the answer. And I hope so. The concept is very, very clear. We lost that. Do one thing in a few seconds. Just 1 minute, please.